3I Atlas, the comets, and the planetary alignments are causing the intense solar flares. That question exploded across social networks as if something were hidden behind the glow of the sun, something that science might have overlooked, something new that was altering the very heart of our star. Many viral videos insist that this interstellar object 3I Atlas arrived precisely when the sun began releasing much stronger explosions, as if its presence were the missing piece of a cosmic puzzle. Others swear that a recent planetary alignment and the approach of unusual comets might be disturbing the solar balance. But how real is any of that? Could something as small as a comet or as distant as an interstellar object truly influence the activity of a star millions of times more powerful than any body orbiting around it? The truth is that whenever the sun enters one of its most active periods, coincidences begin to appear everywhere. A stronger flare exactly when 3I Atlas makes the headlines. A surge in sunspots during a week filled with planetary conjunctions. A Class X flare at the very moment a comet passes relatively close. The human mind is wired to search for patterns, even when none exist. Yet what is happening right now with the sun is real, measurable, and part of a natural process that has repeated thousands of times since the star was born. So why is this particular moment attracting so much attention? Why did the appearance of 3I Atlas spark theories all over the world? What lies behind the coincidence between the solar cycle and these astronomical events? And most importantly, what does the scientific evidence actually say? Everything starts with understanding how a star that never stops changing truly works. Before diving into every detail, welcome to an analysis based entirely on real data, verified observations, and the physics that governs the behavior of the sun. If you are here, it is because you want to understand what is behind this recent increase in solar flares and whether there really is any connection with 3I Atlas, with other comets, or with planetary alignments. Many people on social networks have mentioned during the past few weeks that thousands of individuals have been searching for alternative explanations for what is happening on our star, and that is perfectly understandable. Every time we witness a powerful flare, a geomagnetic storm, or a sudden spike in activity, the feeling arises that something must be causing it. Today we are going to dismantle that doubt with solid science while keeping enough mystery for you to discover why these phenomena coincide, even though they are not related to one another. Before we continue dismantling whether 3I Atlas, the comets, or the planetary alignments are really behind these so intense solar flares, there are 3 things that you have to do right now to help the scientific truth reach more people and not get buried among viral theories. First, please give a like to the video right now so that this analysis based on real physics and verified observations reaches more people who are being bombarded with misinformation. Second, subscribe and turn on the bell to not miss any real-time updates about Solar Cycle 25 and the upcoming events that are coming. And third, go down right now to the comments and write the word cycle, if you understand that these flares are part of the natural solar maximum and not from external objects. With that, we will enter your name into the global registry of those who are following this phenomenon with real science. Do it now. The question that dominates this analysis was born from a striking coincidence. While the sun was increasing its activity with more frequent and more energetic flares, comments appeared on social networks claiming that something external had to be influencing it. For many people, the behavior of the sun seemed too intense to be simply part of its natural cycle. However, to understand any possible relationship, it is first essential to grasp how these flares actually originate. Everything begins in the sun's own magnetic structure, a star that never remains still for even an instant. Its surface is a turbulent ocean of hot plasma in constant motion, where electrically charged internal currents generate a complex and ever-changing magnetic field. That field is neither smooth nor uniform. It is full of twists, turns, and regions where magnetic field lines cross, tangle, and eventually snap. When that happens, the released energy is so enormous that it hurls charged particles into space at incredible speeds, creating what we know as solar flares. To grasp the magnitude of these events, just imagine that a single moderate flare can release more energy than millions of nuclear bombs, and yet for the sun that releases barely an internal adjustment, an expected and inevitable process in its daily dynamics. The active regions where these explosions occur form and disappear constantly, and their intensity depends on the amount of accumulated magnetic energy. The surprising thing is not that the sun is active. The surprising thing would be if it were not. Stars like ours live in cycles where they alternate between quiet phases and intense phases as a result of how their internal magnetic field resets and reorganizes over time. As the sun approaches the peak of its current cycle, it is natural that we see a significant increase in sunspots, flares, and coronal mass ejections. These phenomena are not only predicted, they have been measured and recorded for centuries. Ground-based telescopes, specialized satellites, and space missions dedicated to solar study have shown that these variations are a normal part of the star's life. In this context, the recent flares do not represent anomalous behavior but rather the natural expression of the Sun in its most active phase. However, when the general public notices a sudden increase in images, alerts, and reports about flares, the impression can be quite different, especially when they coincide with news of unusual objects in the sky. The appearance of 3I Atlas precisely during this period heightened the feeling that a connection existed. Being an interstellar object, the idea that it might carry some kind of unknown influence captivated many people. But the physics governing the Sun's behavior is extraordinarily clear. Its activity does not depend on small external objects, no matter how striking they appear. The Sun is an autonomous system, and its activity cycle is determined almost exclusively by internal processes. For anything external to perceptibly alter its behavior, it would need to possess mass comparable to that of a giant planet or approach the Sun at extremely small distances, conditions impossible for comets or interstellar bodies that simply pass through the solar system. Nevertheless, there is something interesting worth mentioning. When a phenomenon generates enough curiosity, the human mind tries to connect pieces that seem related. A strong flare occurs. A new object appears in the headlines. A planetary alignment coincides with a temporary increase in activity, and immediately the feeling arises that everything forms part of the same picture. Yet astronomy is a discipline that demands separating coincidence from causality. Coincidence can be striking, but causality requires evidence, measurements, repeatability, and physical consistency. In the case of the Sun, that evidence always points inward, toward the magnetic engine that drives its behavior. To better understand how this relates to the current moment, it is enough to note that solar cycles have been studied for more than 2.5 centuries. Approximately every 11 years, the Sun shifts from a quiet phase to an active phase in which the number of sunspots can multiply by 100 and the intensity of flares can increase dramatically. This process has occurred even in eras when no interstellar objects had been detected, when planetary alignments were not discussed, and when comets were merely faint lights in the sky. This proves that the Sun follows its own rhythm, independent of external factors. The flares that now draw so much attention are part of that pattern and were already anticipated by scientists monitoring its behavior. What has changed today is the amount of accessible information. Satellites such as the Solar Dynamics Observatory provide constant images of the Sun, and social networks amplify every event. Public perception of increased activity stems not only from the solar cycle itself but also from the speed at which news spreads. When an object like 3I Atlas captures interest at the same time the Sun is passing through its most active phase, the narrative builds itself, even though it lacks physical support. The fundamental point is to distinguish between measurable facts and conclusions driven by temporal coincidence. Understanding solar flares always begins with the physics of plasma and the Sun's magnetic dynamics. That is the starting point for any serious analysis of its behavior, without needing to resort to external influences when the star itself possesses all the energy required to generate these events. What is happening today is the result of processes that have been developing since the beginning of this solar cycle, long before 3I Atlas was detected and long before any planetary alignment caught the public's attention. It is precisely by observing this internal functioning that we find the key to answering the question posed in the title in a scientific way. To delve deeper into what is happening with the Sun, we must focus on something that completely determines its behavior, the solar cycle. This cycle, which lasts around 11 years, is neither a theory nor a modern interpretation. It is one of the best documented astronomical phenomena. Since the 17th century, astronomers from different countries have recorded the rise and fall of sunspots, creating a historical record that reveals a clear pattern. In each cycle, the star's magnetic activity increases until it reaches a maximum where flares, brightenings, and coronal mass ejections become far more frequent and energetic. After that peak, activity gradually decreases until returning to a calmer state. This process repeats over and over again, like the natural pulse of the Sun. In the current cycle, known as Solar Cycle 25, it was already predicted that activity would rise strongly between the years 2024 and 2025. Nothing we are seeing now is unexpected for the scientific community. On the contrary, several space missions were specifically designed to monitor this period. Solar telescopes, orbiting observatories, and probes studying the solar wind have confirmed that the star is behaving exactly as it should during a maximum phase. What seems to many people like a sudden increase is in reality part of a natural process anticipated years in advance. What does happen is that when activity is more intense, it becomes more visible, more dramatic, and more likely to generate concern, especially when it coincides with astronomical phenomena that capture public attention. The reason the solar cycle intensifies is related to the reorganization of the Sun's internal magnetic field. Over the course of the cycle, that field becomes tangled, distorted, and strengthened, creating conditions more favorable for the formation of sunspots. These spots are not mere dark patches. They are regions where the magnetic field is so intense that it inhibits convection and results in lower surface temperatures. The stronger the magnetic field in a given area, the greater the chance of a sudden rupture that releases energy on a massive scale. During the solar maximum, the number of these regions increases significantly, explaining the frequency of flares. Although this information is available to anyone seeking reliable scientific data, popular perception works differently. People observe the coincidence between solar behavior and the presence of striking celestial bodies and look for direct relationships. What is often not considered is that the Sun has been generating these explosions long before objects like 3I Atlas entered the scene. The strongest recorded flares occurred in eras when interstellar bodies were not discussed because they simply had not been detected, yet the Sun continued its cycle uninterrupted. The solar storms of 1859, 1989, and many others happened during cycles in which no unusual object drew media attention. This demonstrates that solar activity follows its own rhythm, independent of small external bodies, no matter how striking they may be. Another reason solar activity seems more intense today is the enormous availability of high-resolution images. If we go back just a few decades, most people never saw a solar flare directly. Now every event can be captured on video, shared in seconds, and go viral within minutes. When a Class X flare appears in reports, millions of people see it almost in real time, creating a sense of urgency that did not exist before. This increased visibility gives the impression that events are more frequent or severe, even when they follow completely normal patterns of the solar cycle. And when that perception combines with news coverage of a rare interstellar object, the human brain automatically connects both elements, even though no relationship exists. It is important to consider how the dynamics of coincidence work in human interpretation. When two phenomena occur at the same time, the mind searches for patterns, tries to weave stories, and makes sense of what it observes. The Sun increases its activity, 3I Atlas appears, planetary alignments are discussed, and everything seems to form a set of connected pieces. However, astronomy demands strict discipline in separating correlation from causation. In science, two events happening simultaneously do not mean one causes the other. Causation requires physical evidence, theoretical foundation, and energetic consistency. In the case of the Sun, the difference in scales is so vast that any attempt to attribute its behavior to tiny bodies loses meaning the moment the numbers are examined. The Sun's internal energy is so gigantic that even the largest planets in the solar system have minimal influence in comparison. Jupiter, the most massive planet, exerts such a tiny force on the Sun's behavior that it cannot even alter its surface structure, much less trigger flares. And if a planet that outweighs thousands of objects like 3I Atlas combined cannot affect the Sun, a small and distant interstellar body cannot do so either. The star follows its internal and externally independent rhythm, guided by the physics of the hot plasma circulating inside it. During the solar maximum, intense magnetic processes completely control the dynamics of the surface, and no small external influence can compete with that energy. Understanding the solar cycle not only explains the star's current behavior but also puts into perspective all the theories that seek to connect it with external phenomena. Once the Sun's behavior is observed from an exclusively physical viewpoint, it becomes clear that any coincidence with the presence of objects like 3I Atlas does not represent a causal relationship. The cycle continues, intensifies, reaches its maximum, and then declines regardless of what happens around it. The activity we see today is simply the consequence of a process that began years ago inside the star itself, long before the world's eyes fixed on an interstellar visitor. To understand why many people link solar activity to the arrival of 3I Atlas or other comets, we must examine in detail what an interstellar object really is and what physical characteristics it possesses. When 3I Atlas was detected, public attention immediately focused on its origin outside the solar system, a feature that makes it an exceptional and extremely rare visitor. Interstellar objects do not follow a stable orbit around the Sun. They travel at extremely high speeds, propelled by trajectories that began long before they approached the solar neighborhood. Their composition, shape, and brightness can be unusual because they come from environments very different from those we are used to observing within the solar system. However, no matter how striking they are, their size and mass are tiny when compared to any planet or even some large asteroids orbiting between Mars and Jupiter. The mass of an interstellar object like 3I Atlas is so low that its gravitational influence is not only negligible for the planets but completely irrelevant for a star like the Sun. A star does not react to small bodies. Its gravitational field absolutely dominates everything around it, and only extremely large masses such as giant planets or even nearby stars could produce any perceptible effect on it. When an object like 3I Atlas enters the solar system, it does so as an additional particle in an immense ocean. Its presence does not represent any physical disturbance capable of altering the Sun's magnetic structure. This difference in scales is so extreme that any attempt to link the two phenomena starts from a misunderstanding of the magnitude of solar energy. Moreover, the fact that an interstellar object is unusual does not mean it possesses unknown or mysterious properties capable of influencing the Sun. The science that studies minor bodies, both inside and outside the solar system, is based on observations, spectroscopy, orbital dynamics, and models that explain how they behave in the presence of solar gravity, from Oumuamua to Borisov. Previously observed interstellar objects have shown that they follow trajectories completely determined by known physical laws, and 3I Atlas is no exception. Its behavior, speed, and trajectory fit perfectly with what is expected of an object coming from interstellar space and passing through the solar system without being captured by solar gravitation. The probable composition of these objects has also been studied from their brightness, how they reflect sunlight, and how they behave. As they approach the Sun, rising temperature can cause them to release gas or dust, creating structures that visually resemble those of a conventional comet. But that behavior generates no interaction with the star because the distance at which they pass is enormous in stellar terms. Even when a comet approaches the Sun much closer than a typical interstellar object, the influence remains one way. The Sun affects the comet. It heats it, sublimates it, and illuminates it, but the comet does not affect the Sun. This relationship always remains the same, no matter how spectacular the object looks in astronomical images. Another point that often raises doubts is the brightness of these objects. When an interstellar body starts releasing gas or dust due to solar heat, it can appear more active or unstable. This leads some people to believe there is a strong interaction between that body and the Sun. However, what happens is simply a physical process called sublimation that affects any icy body approaching the star. The brightness does not represent additional energy or external influence. It is merely the natural response of surface material to solar radiation. That brightness can increase media attention, which in turn generates greater interest. And when that interest temporarily coincides with intense solar flares, the perception of connection arises on its own. The speed at which these objects travel compared to their mass also makes them incapable of generating significant gravitational effects. Although they move faster than most known comets, the kinetic energy of an object like 3I Atlas is irrelevant on the scale of solar energy. A solar flare releases more energy than any small object could contribute, even if it fell directly onto the Sun's surface, something that does not happen in practice because these trajectories do not lead objects to impact the star. The minimum distance between 3I Atlas and the Sun is enormous in stellar terms, far too great to allow any direct interaction. The solar atmosphere and solar wind also help dismantle the idea of external influence from such a small body. The solar wind is a constant stream of charged particles flowing into space from the solar corona. For an object to influence that stream, it would need to possess mass or a magnetic field comparable to that of a large planet, something completely out of scale for 3I Atlas. The solar wind passes through and surrounds small objects without them producing any modification in its behavior. Again, the dominant energy always flows from the Sun outward, never from objects toward the Sun. The most interesting comparison arises when we look at the behavior of 3I Atlas versus bodies that do pass very close to the Sun, such as sun-grazing comets that reach extremely small distances. We observe something even more revealing. Sun-grazing comets, despite approaching much closer than a typical interstellar object, also produce no alteration in solar activity. They disintegrate, form luminous tails, create impressive visual spectacles, but the Sun continues its dynamics without showing any response to their presence. This confirms that even dramatic close approaches by icy objects do not alter the nature of the star. In this context, attributing the current solar flares to the arrival of 3I Atlas not only lacks physical foundation but ignores the massive scale of the solar cycle itself. The star is in a phase where its magnetic fields are particularly active. That internal activity completely dominates the observed behavior. The temporal coincidence between the arrival of 3I Atlas and the increase in solar flares does not represent a causal relationship. It is simply an overlap of independent events that simultaneously captured public attention. When solar data are analyzed, the sequence of events aligns with the expected cycle, not with the presence of the interstellar visitor. Scientific discussion rests on a clear understanding of magnitudes, distances, and energies. In every one of these aspects, 3I Atlas falls far below any threshold capable of affecting the Sun. What it does provide is a new chapter in the observation of interstellar objects, an opportunity to study materials coming from other regions of the galaxy. But its role in the solar scenario ends there, as a distant visitor passing through the system without altering the star's activity. The Sun continues its natural path governed by internal forces that prevail over any minor body. When people talk about comets and their supposed influence on the Sun, interpretations often arise that do not correspond to physical reality. The idea that a comet could alter solar activity has been repeated throughout the centuries, long before telescopes existed that could study the star's behavior in detail. For many ancient cultures, comets were omens announcing extraordinary events, and that symbolic perception has persisted in the collective imagination to this day. Therefore, when a bright comet or a new object like 3I Atlas appears, the connection with intense solar phenomena arises immediately, even though no scientific basis supports it. That human tendency to seek meaning in visual coincidences feeds theories that overlook the energy scale involved in solar processes. To understand why comets cannot cause solar flares, we must look at their physical characteristics. Comets are composed mainly of ice, dust, and organic compounds. Their mass is extremely small compared to that of planets and, of course, insignificant compared to the Sun. Even the largest comets ever recorded are minuscule against the enormous stellar gravity. This means their gravitational influence on the Sun is so tiny that it is impossible to measure. The relationship between the two bodies will always be one-sided. The Sun completely controls the comet's behavior, while the comet lacks the capacity to affect the star in any way. As a comet approaches the Sun, intense radiation and heat cause sublimation of its ices. This generates a bright coma and a spectacular tail, but this process does not represent an interaction that modifies the state of the Sun. It is simply the result of solar energy acting on a fragile body. Both the coma and the tail are formed by material detached from the comet itself, not by any special emission that could influence the star's behavior. The tail always points away from the solar wind, a constant flow of charged particles the Sun emits without rest. This orientation shows that the Sun dominates the interaction, never the other way around. The solar wind passes through the coma and tail without being altered because the density of cometary material is far too low to produce any measurable effect. In the history of modern astronomy, there are numerous examples of comets that have passed extremely close to the Sun, some even disintegrating in the process, without any reaction observed from the star. Space missions such as SOHO have recorded sun-grazing comets entering the solar corona and evaporating completely, yet the Sun shows no change in its behavior beyond its normal activity. This confirms that even the most dramatic close approaches have no potential to trigger flares or alter the solar magnetic field. The energy involved in a solar flare is so great that no comet, regardless of size, can trigger it. Despite this evidence, every time a bright comet coincides with a series of solar flares, rumors resurface. One factor contributing to this mistaken perception is that comets often appear close to the Sun in the sky during certain times of the year, visually coinciding with active regions of the star. However, that closeness is only apparent and depends on the perspective from Earth. The real distance between the comet and the Sun remains immense compared to the scale on which stellar magnetic processes occur. Images may show both bodies in the same region of the sky, but in three-dimensional terms they are separated by millions of kilometers. This visual illusion feeds interpretations that do not reflect spatial reality. Another element contributing to the confusion is the speed at which information spreads today. When a viral image shows a comet with a bright tail at the same time a powerful solar explosion is announced, the mental association forms immediately. For many, the coincidence seems too exact to be chance, but astronomy requires a different approach based on measurements rather than perceptions. Every solar flare can be traced to a specific sunspot region whose behavior is monitored with precision. Nothing in those data indicates that external factors, much less comets, have played any role in the energy release. The Sun's magnetic field originates from the movement of plasma inside the star in a process known as the solar dynamo. This mechanism is complex and depends on the Sun's differential rotation, convection in its interior, and the evolution of its active regions. Flares occur when magnetic field lines stretch, bend, and finally reconnect, releasing accumulated energy. These processes happen deep within the solar structure and cannot be influenced by the presence of small bodies outside the surface. The gravitational or magnetic force of a comet lacks the scale necessary to interact with the solar dynamo. The Sun produces, regulates, and releases its own energy without needing external stimuli. Even if we imagined a comet much larger than any known, its mass would still be minuscule compared to the Sun. To affect the star's behavior, it would need mass equivalent to that of a large planet and approach distances that would endanger its own structure. Even then, the planets themselves, including Jupiter with its enormous size, do not generate perceptible changes in solar activity. Energy dominates from within, not from without. The physics governing the behavior of a star like the Sun is so powerful that any attempt to attribute changes to small bodies lacks real basis. When the phenomenon is analyzed from this perspective, it becomes clear that comets play no role in the intensity of solar flares. What they do is attract public attention, which in turn increases the perception of coincidences. A bright comet in the sky and a solar explosion in the headlines create the illusion of connection, but the illusion disappears once energy scales are compared. The Sun continues regulating its internal activity regardless of how many comets appear in its apparent vicinity. Visual coincidence does not imply physical influence. Science has repeatedly demonstrated that solar activity responds only to processes occurring within its structure. Comets, despite their beauty and cultural impact, do not modify the star's behavior. Their role in this scenario is completely passive, as visitors that light up while passing but lack the capacity to alter the internal machinery of the Sun. Ultimately, today's solar activity depends in no way on comets but on the natural state of a cycle currently at its most intense point. To answer definitively whether an external body could influence solar flares, we must focus on the fundamental physics governing interactions between objects in space. Everything begins with a simple yet crucial idea. The magnitude of the forces involved when two celestial bodies interact occurs mainly through gravity or magnetic fields. In both cases, the scale of those forces is determined by size, mass, and distance between the bodies. It is precisely here that an abyssal difference emerges that rules out any possibility that comets, asteroids, or even an interstellar object like 3I Atlas could have any effect on solar activity. The energy produced by a solar flare is so colossal that it easily surpasses the total energy any body could contribute unless it were at least planet-sized. For a clearer idea, a single moderate-intensity flare can release more energy than all of humanity's electrical consumption over thousands of years. A stronger flare can release even more energy than a giant asteroid would release if it impacted a planet directly. And yet for the Sun, those flares represent merely a local adjustment within its internal magnetic dynamics. The Sun's energy scale is incomparable to that of any small object, so imagining that a tiny body could provoke a reaction ignores this fundamental difference. Gravity is one of the first forces to analyze. Gravitational force between two bodies depends directly on their masses and the distance separating them. The Sun's mass is so enormous that it completely dominates the solar system. Planets orbit it because its mass is sufficient to keep them trapped in stable orbits. In comparison, comets are specks of dust with insignificant mass. Even if a comet were 1,000 times larger than those we know, its gravitational influence on the Sun would still be practically zero. An interstellar object like 3I Atlas has even less mass, making its gravitational influence completely negligible. The Sun's internal energy, driven by plasma movement at millions of degrees, eclipses any lesser external force that might approach. Another important aspect is distance. Solar flares are phenomena that occur on or near the Sun's surface within its magnetic structure. For an external body to influence those processes, it would have to approach an almost impossible distance, so close that impact would be immediate and probably fatal for the body itself. No comet, asteroid, or interstellar visitor approaches closely enough to compete with the energy released in an active region of the Sun. Even sun-grazing comets that pass extremely close to the solar corona fail to alter its behavior. They disintegrate completely due to heat and radiation, but the Sun remains indifferent to their presence. Magnetic interaction is another aspect frequently mentioned in popular theories. Some believe an object with its own magnetic field could disturb solar magnetic field lines and trigger a flare. However, this idea also falls apart upon examining the data. The Sun's magnetic field is thousands of times stronger than any magnetic field generated by a small body. Moreover, objects such as comets and asteroids do not possess significant magnetic fields. Even if they did, the distance between them and the Sun would be too great to allow any interaction. The solar magnetic field dominates its entire environment, extending far beyond the orbit of Pluto through the solar wind. There is no physical possibility for a small object to disturb that field on a stellar scale. Magnetic reconnection, the process that triggers solar flares, occurs when solar magnetic field lines reconfigure violently. This process arises from the internal dynamics of the Sun's plasma and is completely independent of small external forces. Reconnection depends on the Sun's rotation speed, its internal structure, electrical currents within the plasma, and the natural evolution of its active regions. None of this is linked to external bodies. Reconnection happens because the Sun is a sphere of plasma in constant motion, not because something pushes or disturbs it from outside. For an external body to influence a solar flare, it would need extremely large mass, at least comparable to that of a giant planet, and would have to approach the star at a distance where mutual gravitational forces were significant. Yet even a planet like Jupiter, with mass enormous compared to any minor body, does not affect solar flares. Jupiter is massive enough to influence other planets, but its impact on the Sun is insignificant. And if such a planet cannot modify solar activity, much less can a small object only a few kilometers in diameter. Physical logic is unequivocal. The speed at which a body travels also provides no advantage. Although 3I Atlas and other interstellar objects move quickly, the kinetic energy they possess is not transferred to the Sun in any significant way. They do not collide with it, do not alter its field, and do not approach closely enough to interact directly. Speed alone is not a factor capable of provoking a change in solar activity. The energy of a solar flare far exceeds the kinetic energy of any known interstellar object. There is no physical mechanism allowing the presence of a fast but small object to trigger the internal release of energy in the Sun. It is important to highlight that solar activity has remained constant for billions of years, obeying internal processes that have not changed significantly since its formation. If external bodies were capable of altering its behavior, astronomical observations would have shown it long ago. Comets have existed since before humans observed the sky. Planetary conjunctions occur regularly, and solar cycles repeat without interruption. There is no record in scientific history showing that the presence of a comet or a planetary alignment has even slightly altered the nature of a solar flare. When all of this is reviewed with scientific rigor, the conclusion becomes inevitable. The Sun responds only to its own internal mechanisms. Gravity, plasma dynamics, differential rotation, and magnetic evolution are the true drivers behind flares. External objects, no matter how striking, lack the scale necessary to alter these gigantic processes. Physics leaves no room for doubt when analyzed with precise data and understanding of magnitudes. When the idea arises that a planetary alignment could influence solar flares, it usually comes from the human intuition that planets lined up might exert a greater combined force. At first glance, that logic seems reasonable, but only until the real magnitudes involved are compared. To understand why planetary alignments do not affect solar activity, it is essential to analyze gravity in scientific terms and understand how forces operate between the Sun and the planets. Gravity depends on two main factors: the mass of the bodies and the distance between them. Planets, though large from a human perspective, are insignificant compared to the Sun. Even Jupiter, the most massive planet in the solar system, possesses only a tiny fraction of the solar mass. Its gravitational influence on the star is so small that it produces no measurable effect on its surface behavior or magnetic activity. Planetary alignments are events that occur with some frequency, and for centuries astronomers have recorded these alignments without observing any correlation with sudden increases in solar flares. The popular perception that these events are rare or extraordinary is mistaken. Planets orbit in similar planes and with periods that allow multiple partial alignments throughout each decade. Sometimes the alignment looks more impressive from an Earth perspective, but that does not mean the actual distances between planets change enough to create a different physical situation. Planets never approach each other significantly during an alignment, much less alter their distance from the Sun. In fact, from a physics standpoint, the combined gravity of aligned planets remains far too small to generate any change in solar activity. A clear example to illustrate this scale is to compare the influence of the Moon on Earth with the combined influence of all planets on the Sun. The Moon, despite being small, is close enough to Earth to generate tides and affect its rotation axis over long timescales. However, when the gravitational force that all aligned planets exert on the Sun is calculated, the value obtained is lower than what the Moon exerts on Earth. This demonstrates conclusively that planets lack the power to modify solar processes. Solar activity is internal and autonomous, driven by energies that vastly exceed the gravitational influence of any body in the solar system. The solar magnetic field, directly responsible for flares, also functions independently. It is a complex system generated by plasma movement inside the Sun, where extremely high temperatures and intense electrical currents interact continuously. Planetary alignments do not alter solar plasma flow, do not affect its internal structure, and do not influence its differential rotation. Although alignment is spoken of in visual terms, from a three-dimensional perspective, planets continue orbiting in positions that do not represent any special configuration in terms of physical influence on the Sun. The word alignment often creates a feeling of order and combined force, but in reality it is a visual and geometric phenomenon without energetic relevance. The history of astronomy records several examples where it was believed alignments could have dramatic effects. One of the most famous occurred in 1982, when several planets aligned approximately in an event some described as the alignment of the century. Many speculated it could trigger earthquakes, solar storms, or various catastrophes. However, nothing extraordinary happened. Solar activity during that period followed its normal course, obeying only the corresponding solar cycle. This was confirmed again in the year 2000, when another alignment sparked similar warnings in sensationalist media. Once again, the star behaved exactly as it always does, with variations that were its own and expected according to its internal cycle. The lack of impact of alignments on the Sun is neither a mystery nor an open question. It is a conclusion confirmed by constant observations, physical calculations, and models that describe the solar system's behavior with high precision. Planets, though imposing from an Earth perspective, lack both the mass and proximity necessary to influence the solar magnetic field. Their geometric configuration, whether aligned or not, does not alter the Sun's internal dynamics. The energy involved in a solar flare is the result of processes originating deep inside the star, where the forces at play exceed by millions of times any external influence that could come from the planets. Another factor feeding confusion is temporal coincidence. When strong solar flares are reported at the same time as a planetary alignment, the human mind tends to associate them. But this coincidence does not imply causal relationship. In a universe full of cyclic events, it is inevitable that some occur simultaneously without one being responsible for the other. The Sun has a natural activity cycle that continues without interruption, regardless of planetary positions. And since alignments occur regularly, it is natural that on some occasions they coincide with periods of greater solar activity, generating the illusion of a non-existent connection. When solar behavior is analyzed with the precision offered by modern instruments, it becomes clear that solar activity responds exclusively to internal processes. Active regions producing flares can be tracked from formation to disappearance. Sunspots follow established patterns and behave according to the evolution of the solar magnetic cycle. None of these processes show alterations related to planetary positions. Contemporary solar science has powerful tools such as satellites dedicated to constantly monitoring the surface, corona, and solar wind. If alignments had any effect, these instruments would have detected variations in intensity, frequency, or distribution of flares. No such evidence exists. Even when considering the hypothetical possibility that planets could combine their gravity differently during an alignment, physics shows that the resulting force remains minuscule compared to what dominates the Sun's interior. Stellar dynamics operate on such colossal scales that planets represent nothing more than small disturbances in outer space, incapable of generating effects inside the star. The idea that an alignment could influence solar flares has no basis in any valid physical theory or observational data. Over centuries, astronomers have demonstrated that the Sun does not depend on external factors to produce its activity cycles. Planetary alignments have been observed repeatedly without producing changes in stellar behavior. The Sun's energy comes from its internal processes and is released following natural patterns that do not respond to planetary positions. The notion that an alignment could trigger a solar flare lacks scientific foundation and contradicts everything we know about stellar physics. When we try to understand why so many people believe external phenomena are influencing solar flares, we must examine a component rarely mentioned in technical texts but which plays an enormous role in public perception: human interpretation and the way information is transmitted in the digital age. Social networks, short-form videos, viral posts, and news fragments circulating without context create an environment where complex scientific concepts are simplified or distorted until they generate completely mistaken impressions. This phenomenon is not exclusive to astronomy, but it becomes particularly intense when it comes to the Sun, an object that by its nature seems mysterious and imposing. Solar activity can produce dramatic images, colossal explosions captured in high resolution and sequences that look like they belong in a movie, making it easy for any visual coincidence to become a convincing narrative. The psychological mechanism behind this search for connections is well known. Human beings tend to detect patterns even where none exist. This tendency has been reinforced in recent years by the amount of instantly available visual information. Every solar flare, every active region, and every change in the corona can be seen clearly through images taken by dedicated satellites. These striking images go viral quickly, reinforcing the feeling that something extraordinary is happening. When this phenomenon coincides with the appearance of an interstellar object like 3I Atlas, the combination becomes irresistible to the human mind, trying to unite both events as if they formed part of the same picture. Temporal coincidence gives the impression of causality, even when scientific data demonstrate the opposite. Furthermore, the way astronomical phenomena are communicated contributes to this confusion. Phrases such as extreme solar activity, unusual explosion, or unprecedented events are often used in headlines designed to capture attention. Although these headlines do not accurately reflect scientific context, they do generate an exaggerated perception of the event. When the public sees these headlines alongside news about a planetary alignment or a particularly bright comet, they conclude that both phenomena are related. The lack of accessible scientific explanations in many media contributes to the spread of these mistaken interpretations. Another factor fueling wrong theories is the accelerated pace at which information circulates. A solar flare can be detected in real time, and within minutes comments, videos, and posts appear trying to explain what happened without access to complete data. This speed generates incomplete analyses or assumptions based on isolated images. Instead of waiting for a detailed scientific report, most people consume immediate content lacking context. When these posts include images of comets, planets, or interstellar visitors, the perception of connection grows even stronger. Space images, now accessible to anyone with an internet connection, also contribute to the apparent relationship between phenomena. For example, when SOHO waves or the Solar Dynamics Observatory capture the approach of a sun-grazing comet, the images can show both objects in the same visual region. For someone without training in astronomy, that apparent closeness is interpreted as real proximity. The difference between visual alignment and enormous physical distance is not evident without a deep understanding of three-dimensional space. That confusion leads to interpreting the comet's presence as a factor capable of influencing solar activity, even though the real distance between them is sufficient to rule out any interaction. Cultural construction around comets also contributes to attributing them power they do not have. For centuries, comets were considered signs of change, messengers of future events, or symbols of impending catastrophes. Although today they are understood scientifically, that symbolism remains present. When a comet appears close to the Sun or crosses the sky unusually, the collective imagination revives these ancient associations. The mixture of cultural tradition, impressive images, and alarming headlines creates a perfect environment for the proliferation of unfounded theories. The lack of deep knowledge about solar physics amplifies these perceptions. The functioning of the Sun is not intuitive. Magnetic reconnection, plasma dynamics, and differential rotation are not simple concepts. For most people, it is easier to imagine that an external object is causing a flare than to understand the complex interaction of magnetic lines inside the Sun. This gap between science and popular interpretation is frequently exploited by sensationalist content that presents simple but incorrect explanations. In many cases, these theories are more attractive than scientific reality precisely because they offer a clear, albeit false, narrative. An additional element reinforcing these ideas is the lack of historical context. Many people are unaware that the Sun has experienced intense activity during every recorded solar cycle, even in eras when interstellar objects were not discussed. The solar storm of 1859, known as the Carrington event, occurred in a period when no one spoke of comets influencing the Sun. Nevertheless, it was one of the most intense flares ever recorded. The storms of 1989 that caused blackouts in Canada also did not coincide with bright comets or special planetary alignments. This historical context demonstrates that extreme solar activity does not need external coincidences to manifest. The unpredictable nature of solar flares also feeds mistaken interpretations. Although science understands well the basic mechanisms behind these explosions, predicting the exact moment a given active region will release a flare remains a challenge. This difficulty creates space where alternative explanations proliferate. When science cannot say precisely when a flare will occur, many people look for answers outside the sun's internal processes. However, this uncertainty does not mean comets or alignments have influence. It simply reflects the inherent complexity of an object whose behavior is governed by gigantic and constantly moving magnetic interactions. Sometimes even isolated comments from public figures can contribute to the idea of a connection. A misinterpreted comment, an oversimplified explanation, or a statement taken out of context can go viral and reinforce incorrect theories. Instant dissemination and constant repetition amplify these ideas to the point that many people accept them without question. Information that appears visually or emotionally convincing usually has more impact than scientific information, especially when presented attractively. When all of this is combined, human psychology, popular culture, massive dissemination of images, and lack of scientific context, it becomes understandable why so many people believe events such as the arrival of 3I Atlas or planetary alignments are associated with solar activity. The perception of connection arises naturally, even if physical reality completely rules it out. Science demonstrates that the sun is autonomous in its behavior, but the human mind continues searching for patterns to make sense of the universe. To understand why current solar activity generates so many mistaken interpretations, it is helpful to observe how access to information has evolved over the past decades. Before, the study of the sun was reserved for scientific institutions, specialized laboratories, and professional astronomers who analyzed data with exclusive instruments. Today, anyone with a phone can see real-time images of the sun. Missions such as the Solar and Heliospheric Observatory, the Solar Dynamics Observatory, or probes traveling through deep space transmit impressive images that go viral in seconds. This accessibility seems at first glance an extraordinary advance for scientific outreach. However, it also created a scenario where interpretation without context became common and where images requiring technical analysis are consumed as simple photographs without explanation. The direct consequence of this massive availability is that many people interpret data intuitively, basing their understanding more on visual appearance than on the physics behind what they observe. When a solar flare appears as a gigantic flash in an accelerated video, it seems extraordinary. When an active region is seen expanding on the sun's surface like a bright vortex, the impression is that something highly unusual is occurring. The timescale of these images, often shown in a few seconds although they represent hours of real activity, also contributes to creating an exaggerated perception. People end up believing the sun explodes several times a day or that its behavior has intensified suddenly. But these impressions are the result of how information is visually presented, not the real state of the sun. Moreover, solar images often include visual artifacts, saturation effects, and optical phenomena produced by the instruments used. The solar corona, appearing as a bright halo, can change shape depending on the filter or observation angle. When a small object passes through the satellite's field of view, it can appear as a luminous point that some immediately interpret as a comet or something stranger. There are occasions when dust fragments, charged particles, or even internal reflections of the instrument generate optical illusions that go viral as supposed extraordinary events. When these images mix with news of intense solar flares, the mistaken narrative is reinforced. Another aspect fueling confusion is the lack of understanding of real scale. For someone unfamiliar with astronomy, seeing an object near the sun in an image can be interpreted as literal closeness, when in reality that object may be millions of kilometers from the star and the apparent proximity is only a coincidence of perspective. Space cameras do not show three-dimensional depth. So many times two bodies appear together when they actually occupy completely different regions of space. This lack of spatial reference contributes to the belief that comets or interstellar visitors are physically interacting with the sun when they are not. The human need to find quick and clear explanations also plays an important role. Solar flares, due to their complexity, do not always have an immediate explanation available to the public. The magnetic processes occurring on the sun's surface are difficult to visualize and even harder to express in simple words. Because of this, many people turn to alternative explanations that seem more accessible. The influence of a comet visible in the sky, the arrival of a striking interstellar object, or the alignment of planets that is easy to imagine as a combined pole. These explanations have the advantage of being intuitive, even if incorrect. In contrast, the real physical processes of the sun require technical knowledge and understanding of concepts not part of everyday education. The problem grows when these mistaken ideas mix with theories already existing in the collective imagination. For example, the idea that planets influence human destiny since antiquity leads some people to believe they could also influence the sun's behavior. The notion that comets bring change or signals has been present in multiple cultures for thousands of years and persists even in modern times, now wrapped in pseudoscientific language. The appearance of an interstellar object, already enough to spark the imagination, becomes a focus of speculation when it coincides with an increase in solar activity. The combination of these elements creates an attractive narrative that is easy to spread and difficult to refute without extensive explanations. Even within scientific outreach there are challenges. Many well-intentioned communicators seek to simplify solar phenomena so the general public can understand them, but in that attempt at simplification some critical details can be lost, leading viewers to incorrect conclusions. If it is mentioned, for example, that the sun is more active than normal without explaining that this behavior is completely expected within the current solar cycle, the audience may interpret that something unusual is occurring. And when this incomplete idea mixes with information about comets or planets visible in the sky, the perception of a relationship becomes inevitable. The speed of circulation also generates an additional problem. In many cases, a solar flare is reported in real time, but its complete analysis requires hours or days. The first publications, which are the most widely shared, usually lack context or deep scientific explanation. By the time the detailed analysis is published, popular interpretation is already formed. This phenomenon creates a gap between science and public perception that becomes difficult to close, especially when the initial narrative involves spectacular images and attractive speculations. Another important element is the lack of familiarity with the sun's behavior in its normal state. Many people do not know that the sun is constantly active, releasing particles, generating small flares, and moving its magnetic field even in quieter phases of the cycle. When someone sees a recorded flare on video for the first time, they may believe it is a rare or exceptional event, although such events occur regularly. This lack of reference feeds the perception that the sun is reacting to something external when in reality it is simply following its natural behavior. Trust in visual interpretations also affects how scientific explanations are received. For the general audience, an image or video usually has more impact than a detailed text or technical analysis. When a viral image shows what appears to be a comet approaching the sun, that impression can remain even after an expert explains that the real distance was enormous and no interaction occurred. The emotional force of images often surpasses the logical force of scientific arguments. The sum of all these elements, massive access to images without context, intuitive perception, cultural symbolism, sensationalist headlines, and lack of technical knowledge, creates fertile ground for mistaken ideas to spread quickly. Although solar physics clearly demonstrates that solar activity is autonomous and independent of comets, interstellar objects, or planetary alignments, the popular narrative continues connecting phenomena that coincide in time without any physical relationship. To understand clearly what is truly intensifying solar flares at this moment, we must return to the physical processes occurring inside the sun that determine its current behavior. The solar activity we observe is neither random nor responsive to external phenomena but is deeply linked to the evolution of the star's internal magnetic cycle. The sun is a sphere of plasma in constant motion where electrical currents, extremely high temperatures, and extraordinarily complex magnetic fields interact ceaselessly. These processes develop on scales that surpass any other phenomenon in the solar system, turning the star into a natural laboratory of colossal energies. In this context, the flares we see intensifying today are the direct result of the advanced phase of the solar cycle in which we find ourselves. The current cycle, following conventional numbering and known as solar cycle 25, entered its most active stage after several years of gradual increase. This increase is a natural part of solar dynamics. In the early years of the cycle, the number of sunspots is low and flares are infrequent. However, as the internal magnetic field reorganizes, energy accumulates on the surface, especially in regions where magnetic field lines become entangled. These zones, known as active regions, multiply as the cycle progresses. It is precisely in these regions that the brightenings and coronal mass ejections that attract so much attention originate. The reason the solar cycle is particularly active now is due to the nature of the solar dynamo itself, a process that converts internal plasma energy into a dynamic and changing magnetic field. This dynamo is the heart of solar behavior. When the dynamo intensifies, the magnetic field becomes more complex and magnetic lines tangle more frequently. This tangling is crucial because it determines how much energy can accumulate before being released in a flare. In an advanced cycle like the one we are living through, active regions can reach extremely high levels of magnetism before breaking and explosively releasing their energy. Another important factor contributing to this intensity is the inclination of the Sun's magnetic axis, which varies throughout the cycle. When the magnetic field is in the process of reversing polarity, which happens approximately every 11 years, activity increases significantly. This polarity reversal is part of the Sun's larger magnetic cycle and usually coincides with periods of greatest sunspot activity. Phases close to the maximum are particularly prone to producing Class X flares, the most energetic of all. Under these conditions, the Sun releases gigantic amounts of energy in the form of ultraviolet radiation, X-rays, and charged particles that propagate into space. Recent solar behavior has been carefully monitored by various space instruments. The data show that active regions have grown in size and magnetic complexity, explaining why flares have become more intense. The elevated activity is neither surprising nor anomalous. It fits perfectly with what is expected of a solar cycle near its maximum. The strong flares and coronal mass ejections recorded in recent weeks are part of a pattern completely consistent with previous studies, and their characteristics such as duration, intensity, and location on the solar surface align with what we know from other similar cycles. The solar wind, the constant stream of charged particles flowing from the corona into space, also plays a fundamental role in how we perceive solar activity. During solar maximum periods, the corona heats more and expands, increasing the speed and density of the solar wind. This increase can intensify interactions between the solar wind and Earth's magnetic field, which in turn can lead to geomagnetic storms when solar particles find weak points in the terrestrial magnetosphere. These storms can generate spectacular auroras and, in intense cases, affect electrical systems, satellites, and communications. However, these effects do not represent a new external influence on the Sun but simply the natural consequence of the solar cycle at its highest point of activity. It is important to emphasize that extreme solar activity does not imply that the star is behaving dangerously or unusually. The Sun has produced much more intense events in the past, even in eras when humanity lacked tools to detect them. The difference today lies in our monitoring capacity, which allows us to record events with precision and show them to the public in real time. But this increased visibility does not turn the solar cycle into something extraordinary. On the contrary, it confirms the cyclic and predictable nature of solar activity. When solar flares coincide with phenomena visible in the sky, such as bright comets or an interstellar visitor, the impression arises that these elements play a role in the intensification, but scientific evidence demonstrates the opposite. Data collected over decades show that the strongest flares, as well as the most active periods, occur independently of the presence of minor bodies in the solar system. Everything we see today is the result of a cycle that was already underway long before 3I Atlas was detected. Scientific understanding of the solar cycle also shows that current activity will gradually decrease in the coming years as the cycle moves toward its descending phase. This pattern has occurred more than 200 times in recent recorded history by astronomers, and each time it follows similar behavior. Intense flares will continue to appear during the months around the maximum, but afterward they will decrease without any external intervention. The Sun will naturally return to a calmer state, driven solely by its internal dynamics. The key to understanding why current flares seem so intense is the combination of the advanced phase of the cycle and the massive availability of images. The phenomenon is real, but mistaken interpretations come from associations without physical basis. Solar activity follows a natural pattern that science has confirmed time and again. What is happening today is not a response to the presence of comets, interstellar visitors, or planetary alignments but the inevitable consequence of an internal process that has repeated for billions of years. When we reach the end of such an extensive analysis, the central question reappears forcefully. If it is not comets, planetary alignments, or the arrival of an interstellar object like 3I Atlas causing the intense solar flares, what really is happening? The answer, supported by decades of scientific observation and modern understanding of solar physics, is that the Sun is simply following its own natural path, driven by internal forces that have guided its behavior since its formation more than 4 billion years ago. The intensity we are observing today does not represent an anomaly or external phenomenon but the culmination of a process that repeats predictably in every solar cycle. The Sun is a gigantic energy machine, a body whose internal dynamics surpass in complexity any other object in the solar system. Its behavior is determined by physical conditions that do not depend on small external factors. Although the presence of interstellar objects like 3I Atlas awakens the imagination and seems connected to the increase in solar activity, the data show that the star does not respond to bodies of such insignificant mass. The Sun is currently in an active phase because that is how its natural cycle works. Every 11 years its magnetic field changes, reorganizes, twists, and reverses, causing an increase in the formation of sunspots, active regions, and flares. This process occurs independently of whatever passes near the solar system. When the recently recorded strong flares are examined, all of them can be traced to well-defined active regions whose evolution has been observed for weeks. These regions formed from accumulations of magnetic energy within the solar surface, not from external influences. The magnetic reconnection that releases that energy is a purely internal phenomenon driven by plasma movement inside the Sun. No small object has the capacity to modify that movement or alter the patterns that determine it. This understanding is fundamental because it allows us to separate visual coincidences from real physical relationships. The contrast between popular interpretation and scientific evidence is especially clear when reviewing the history of astronomy long before modern instruments existed. The Sun already experienced intense cycles that caused auroras visible even at equatorial latitudes. These events occurred when humanity was not even aware of the existence of interstellar objects or that planets could appear aligned in the sky. Intense solar activity is an intrinsic characteristic of the star, not a phenomenon triggered by external bodies. If previous cycles are compared, the current intensity aligns perfectly with what has been recorded numerous times in the past, further reinforcing the idea that the Sun's behavior is autonomous. Another essential aspect is how we interpret the information we receive today. The availability of real-time images makes any solar event seem extraordinary, even if it is routine within the cycle. The public is not always familiar with what a solar cycle means or with the natural variability that characterizes the star. When viewing images of enormous flares expanding over the corona, an impression of danger or unusual activity is generated. But astronomers who continuously monitor the Sun know that these flares are part of the normal behavior of a star that produces energy through extremely intense nuclear and magnetic processes. The Sun's capacity to generate activity by itself is so overwhelming that any comparison with external objects falls completely outside the scale. Comets, even the largest and brightest, are composed mainly of ice and dust. Their mass is so low that they lack the power to affect the solar magnetic field or its surface structure. Despite this, visual experience often deceives. Seeing a comet approach in an image captured by a probe may suggest interaction, but no known comet has ever altered solar activity. Planetary alignments, for their part, are geometric events without physical impact. Although perceived as special or rare, they do not significantly modify distances or gravitational forces. The combined gravity of the planets is infinitesimal compared to the Sun's internal force. When an interstellar object like 3I Atlas appears, the narrative becomes even more tempting. It is natural for a visitor from outside the solar system to awaken curiosity and generate speculation. But although these objects are fascinating from an astronomical point of view, their influence on the Sun is zero. Their mass is too small and their trajectory too distant to cause any disturbance. Their presence coincides with the solar maximum simply because both events occurred in the same period, not because a causal relationship exists between them. Temporal coincidence does not alter physical reality. The Sun is in a moment of great activity because that is how its internal cycle works. When all of this is put into perspective, the conclusion becomes clear. The Sun as a star operates under physical laws that determine its behavior autonomously. No comet, interstellar object, or planetary alignment can modify the internal dynamo that feeds its magnetic field or trigger flares requiring immense amounts of energy. The Sun is acting today as it has countless times before, in accordance with a natural cycle known and studied for centuries. The intensity of its flares is not a sign of external influence but of an internal process reaching its maximum point. The human tendency to seek connections does not change the facts. Science provides tools to distinguish between perception and reality. And the data show conclusively that current solar flares are the result of a natural cycle and not the arrival of an interstellar visitor or the position of the planets. This understanding allows us to appreciate the grandeur of the sun without resorting to mistaken explanations. The star continues vibrating with the energy of an advanced cycle, a phase that will naturally pass in the coming years as it has done countless times since its birth.